In this question, it is given that if beta is equal to limit of this whole where x tends to 0, then the value of 6 beta is dash. You have to fill in the blank. Beta is equal to limit x tends to 0. This part tends to 1. This part also tends to 1. And this part tends to 0. What I do, I add and subtract 1. That is what I mean to say. I write it as e to power x cube minus 1 minus 1 minus x cube to the power 1 by 3 minus 1. Here minus 1 and this is actually plus 1. Plus 1 minus x square whole to the power 1 by 2 minus 1 into sin x whole upon, it is x sin square x means x cube into sin square x upon x square. What is the benefit of subtracting and adding 1? You will understand in next step. That is, I will be writing it as limit x tends 0 e to power x cube minus 1 minus 1 minus x cube to the power 1 by 3 minus 1 plus 1 minus x square whole to the power 1 by 2 minus 1 into sin x whole upon x cube. I have taken the limit of this part, which is 1. But note that you are allowed to take the limit of a part of the question provided that part is in multiplication or division with remaining whole question, and limit of that part is non-zero finite also. If both these conditions are satisfied, that limit of that part is non-zero finite also, and that part is in multiplication and division with remaining whole question, then you are allowed to take the limit of a part of the question. And in next step, I am breaking it into parts. That is limit x tends 0 e to power x cube minus 1 by x cube minus limit x tends 0 1 minus x cube whole to the power 1 by 3 minus 1 by x cube plus limit x tends 0 1 minus x square whole to the power 1 by 2 minus 1 upon x cube into sin x. While coming from here to here, I have used a concept that limit x tends to a. Suppose this is written, and it is very easy for me to see that the limit of this is a finite number. Then I am allowed to write that is, I am allowed to break the limit provided limit of at least one part is a finite number without worrying about the limit of other part. If limit of one part is a finite number, you are allowed to separate. But the similar thing in multiplication I just now told was if this is written for this operation to be allowed, this should be non-zero finite. In the previous case, this was allowed if this is a finite number. But in this case, this is allowed only if this is a non-zero finite. If it is non-zero finite, no need to worry about this. Whatever is this, no problem. Main thing is, if one part is non-zero finite, we are allowed to break in the case of product. Similarly, in the case of plus or minus, you are allowed to break provided the limit of one part is finite number without worrying about the limit of other part. Whatever is the limit of other part, that makes no difference. Similarly, in the case of upon, we are allowed to write provided the limit of this is non-zero finite. That is in the case of plus or minus, for breaking limit of a part should be finite number. But in the case of multiplication or division, we are allowed to write this thing provided the limit of a part is non-zero finite. And these concepts I'm going to use in this question. If you don't take care of these things, you may get wrong answer. This is clearly one minus. For doing this thing, it will become easy for me if I suppose x cube as t. The question will become limit t tends 0 1 minus t whole to the power 1 by 3 minus 1 upon t, and it is very easy to find the limit of this. It is just board level now. Plus limit x tends 0 1 minus x square whole to the power 1 by 2 minus 1 upon x square, and in second part sin x upon x, the limit of this is 1. We are allowed to take the limit of that part separately. This is equal to 1 minus. There are so many ways of doing this. The best will be this part can be found. The value of this part can be found very easily. This will be written here. Plus, again for this part, I can write it as y tends 0 1 minus y whole to the power 1 by 2 minus 1 upon y. The limit of this is 1. This is also very easy, just board level. Here I have supposed x square as y, and I know it is very easy. Still, for completeness, I am calculating the limit of this. Limit t tends 0 using L'Hopital's rule 1 by 3 1 minus t to the power minus 2 by 3 into minus 1 upon 1, and it will become minus 1 by 3. And for this part, again using L'Hopital's rule, we'll be getting 1 by 2 1 minus y to the power minus 1 by 2 into minus 1 upon 1. That is, it will be minus 1 by 2. Hence, my final answer will be 1 minus 1 by 3 minus 1 by 2. This will become 5 by 6. Hence, I have got beta equal to 5 by 6. That is 6 beta equal to 5.